All right, I think we're live. Hello, folks. If you're watching it live right now, hello, I'm Jonathan DeGroot. If you're watching this back, I'm still Jonathan DeGroot. That doesn't actually change that much, but I'm so happy and thrilled for you to be joining us today. I'm Jonathan DeGroot. I don't know if I've said that enough, from Serverless Guru, your guide to cloud excellence. I'm thrilled to be joined today by Tycko Franklin. I've made sure not to say Tycho. I've promised him that as much as he walks us through his clever solution to building a dynamic game server for the hit game Factorio. I haven't played it, but it looks like a lot of fun. So I'm really excited to see what he does with it. So Tycko is going to share his designs, lessons learned from the build, and how his gameplay experience has changed now that he can spin up servers and down at will, which is really, really cool. I'm really thrilled to be here. And without further ado, I'm going to bring Tycko up onto the stage. Hey, Tycko.
Hey, Jonathan. Good to meet everybody. Hope you enjoy this. My name is Tycko Franlklin. I do answer to Tycho, but it is Tycko. And I'm a software engineer and a AWS community builder. Today, I'm going to share about my experience with ECS Fargate, trying to host and succeeding to host uh, a game, Factorio. So is my screen coming through?
Not right now. If you could share that in the background or on the stage, I can get that up.
Share screen. Entire screen. There we go.
Perfect. All right, you're all good.
All right. So here's start of the presentation. I'm going to go through a little bit about the history, what the parts are, and then dive right into the code. Going to aim for a little bit more 400 level, going through the code and then going through AWS, the actual deployed solution, seeing where it's at, and then at the end fire up Factorio. So if you have Factorio, we'll post the the IP address into the chat, and that way anybody watching live can see if they're able to connect as well. So the game I chose was Factorio. It's about building factories. It's top-down 2D builder with a little bit of 3D in there. It's a lot of stuff that seems like diagramming, a lot of challenges to solve. It's just enough similar to the 1 second. It's just similar enough to the stuff I do in my day job, that it's same sort of skill set, but it's just dissimilar enough that it's enjoyable to do and relaxing to do after a hard day's work. So in Factorio, you build up resources, you build factories, you do a lot of diagramming, and it's a pretty fun game. So I first found a server solution that was ECS EC2 based as a CloudFormation template. And Chandler created a CloudFormation template. Link is here, and it was good. It did the job. It's actually very easy to get started in it, but it can be a little painful to maintain and then spin down to zero, especially if you need to up the resources that are required for later game in Factorio. Those can get a little bit more expensive, so I like to turn it off, and there's just a little bit more to do. So it uses a Docker image provided by Factorio tools, and this spins up a Factorio server in Docker. So this was great, but we could do better. I wanted to put in AWS CDK, and then I wanted to try out using ECS Fargate instead of ECS EC2 based solutions. Get it into that serverless realm where we can spin it up when we want to play it. We could leave it on all day if we want to, or spin it down to zero and not be paying for the server compute. So a little bit about the CDK project. It's a very simple diagram. Have a VPC, virtual private cloud that the Elastic Container Service sits in. It has the cluster that then has a service, and the service will keep the Fargate task online. If there's an error, if it needs updating, it'll go ahead and spin down the current one and then spin up a new one. It's self-healing. We could have multiple instances of it going, but for my personal needs in the game server, it works with just one. So we also use Elastic File System to store the data files and the saves. This keeps it persistent storage, so as the compute spins up and down, we don't lose our saved files or progress, especially if like some we spent hundreds of hours in the game. So it provides a really robust solution, and I went ahead, took this architecture and tried to put it into CDK with some success. Here you can get the GitHub uh, link for it and pull it down, and there's instructions to do it yourself if you want to do that after this. So now I'm going to go ahead and go into a code walkthrough, and I did the wrong button. Let's get that sharing going again. There we go. So here we're going to start. We're just going to walk through the project from start to finish and talk a little bit about where it is, things I'm working on, and then what each part is. So it's in TypeScript, and so we have a package JSON that brings in our dependencies. Very lightweight TypeScript AWS CDK with a few other dependencies. So start with our env file, filling in some basic names and what the account is, where the region is, and deployment type if we wanted to do deployments like development, staging, and production. The next step, we go up to our bin file and we pull in our configuration from our env, and then we build the different constructs. I've been messing around with also doing an EC2 uh, solution with ECS, and I'll get more into that later. But for now, we're going to concentrate on the ECS Fargate solution. So first up, I have an infrastructure stack. This one, all it is right now is creating a VPC. So we create the VPC, give it a CIDR range. This one, it's decent. It's namespaced within the VPC, so it doesn't really matter as long as there's at least a few IP ranges in there for the resources that are needed. With the Fargate, because it is uh, a game server that want to play with friends, we do want it exposed to the public. So with ECS Fargate, it's very easy just to say I want it to have a public subnet, and then we can place it in there and get access to the public IP. We give it a roll, get some flow logs going in there, just to be able to log some things, and then we're pretty much done here. Something that I do is instead of passing around references, I like to do a global store for the resources that I create that I later reference. So I just do this with a simple lookup, give it a key, and then whatever it is I am storing, in this case a VPC. I have both a add VPC and get VPC so that I just keep those IDs to the CDK stack uh, unique, and then I can access them from anywhere. So going back to here, that's all this is. Very simple, straightforward. Takes a very short amount of time to deploy. Last night I was testing it out. I tore everything down and then deployed out, and is deployed within a couple minutes. So next up, if we go back to our bin file, we have our Fargate server stack. This one's going to be a little bit more complicated. So I go in and first thing I do, we always want to have logs. So go ahead and create a log group and name it what I want to. I don't really care about keeping it long term. So if I tear this down, I go ahead and have it destroyed. To prevent you know, some issues with dependency gridlocks, deadlocks, go for a lookup. So I create another resource that looks up the current VPC. And because of the other place where we give it a name, VPC name, just go ahead and able to reference that. So we get a reference to our VPC without deeply coupling the stacks. And then we go ahead and start adding the various needed resources. So we start with a role. We need a role. Give it a specific managed policy, can execute the task. So we start with that. And then we give it a security group. Uh, Allow all outbound. It's a server. We want to be able to pull things in as needed. It will pull in the latest Docker file for the Factorio server. So we want to make sure that anything it needs, it can go ahead and grab. So give it a name. This we will come back to, but I also have a EC2 EFS maintenance security group in case I want to get in and modify the files. There are some better ways to do this. I haven't implemented them yet, but we'll come back to that. And then we just add a ingress rule that all TCP from that security group can access the EFS. So then we define the elastic file system. Just again, give it a name, put in the VPC, you set up some properties on it, and give it the name. So because it's in the VPC, because we have the security groups in place, anything the server wants to do with it, I'm fine with. So I don't really limit the access to it, and just give the access there. And do that with the base path with an access point. And then I always keep these around for our Fargate different settings that we can do. It can be a little annoying to look those up. So starting out, I think this was actually last time I deployed this. This was for a later game. So give it basically 4 virtual CPUs with 8 gigabytes of RAM, and that takes care of a lot of our needs with the what the Factorio server needs, and keeps us playing pretty smoothly far into the game when there's a lot of resources and a lot of need on the server. So we set up the configuration for memory and CPU. We give it the task role, and then set up the network mode for VPC. We attach the volume, which then attaches to the EFS again that we created above. Now we define the task by adding a container and give it a name. We pull the image from Factorial Tools, basically latest stable, and then we add the logger configuration in there. Factorio needs these ports open for UDP and TCP. So we go ahead and add that to the container to map from the Docker container to the external network. And then we again add the mount points to the container, which links up the Fargate mount points on the task to the internal mount points on the container. And we do not want it read-only because we want to save. We want the server to be able to track our progress and save that, so we'll read-only false. And then go ahead and add some security groups. We add the ingress rule from above for the EFS. Go ahead and just whatever it wants to do from that security group, This could be a little bit locked down, but I'm fine with all access there from that security group. Then we've already mapped above from internal to the Fargate task. Now we say from the Fargate task to external, go ahead and add those TCP and UDP ports to be able to connect to from external. Next, we add the cluster. So you have a cluster, then the service within the cluster that runs the task. So we add everything from above to the cluster. Or first create the cluster, then add the service, which then adds um, the cluster and the task definition here. Desired count, again, we could put this up if you were running a bunch of different servers and you wanted people to connect between them. This would be a really good solution for being able to keep those all running. For my needs, I only need one, so that's good there. It's either on or it's off. So we have the min healthy and the max healthy is 0 and 100. And this, I believe, allows us to spin it down to 0 if we want. Capacity provider, I use Fargate Spot. I do not need the redundancy and I do not need it to be ensured that it will continue running. If it needs to reset, if AWS needs to pull back that spot instance for something, we get a little bit of warning, and then the server saves and stops. I've actually not had that happen. It's the more often than not, if the server resets, it's because of updates, and that's a very quick process. I think it takes about a minute for the Fargate task to spin back up and then be ready with the server starting within it. So this one, propagate tags from the service. I want to be able to add some tags to it. I didn't quite get to it, but we'll be talking a bit here about the Lambda. Making a Lambda that has a function URL that I can just hand out to my friends that anytime they want to connect to the server, they can just hit that URL, and then it will look up the task, the service, and the cluster, and use this tag to find the right server and return an IP address to it. And let's see. So that's about it for what it takes to deploy out. So if we do run into something where we're monitoring it and the memory is not high enough, or it's getting pretty high there, we can come back in here and change this and then deploy out. It'll stop it, restart it, and get it to the new deployment. If we're starting a new server and it's early stage for Factorio, it does not need a lot. This could be moved down to maybe 1 CPU and maybe 2 gigabytes to save some money there. But generally, it's not too expensive to run it this way either. So I generally leave this alone, but we can go in here and modify it as needed, hit deploy, and it'll go back up and run. So now I'm going to jump over to the on AWS. Going to start with the VPC. Just show the deployed stuff that I deployed this morning. I was thinking about doing a live deployment, but I wanted to make sure it was working. Didn't want to have any demo issues, so when I deployed it this morning with no issues. So here we have a Factorio server, VPC. It has route tables. It does have a public subnet so that we can hit it from outside. Just bringing it up, this is one of the only cases that I use public subnets, but serverless usually go through other means like CloudFront or API Gateway and don't have to worry about this. So almost always start with private subnets. In this case, I feel it's warranted to do a public subnet. We have the VPC. Then if we go over to ECS, we can see that it has the Factorio server cluster. It has one running. I'm going to go into here. There's various things that we can look at here. You can take a look at metrics. Don't have much right there. Honestly, I don't go through too much of these, um, and haven't really spent much time with the server to look at it. But if we go into the service, this will keep one task running. Uh, if for some reason there was some error setting it up and the task failed, it'll actually keep trying to run it and run it and run it, at least for a while, and keep stopping the aired out task and then running again. Thankfully, the work done by others with the Factorio Docker image and just the nature of the system. For Fargate, I have not seen this fail. It just works like a charm. So if we go into the service, here we can see CPU utilization. I think this is where I I connected to it this morning. But otherwise, it's running at pretty low CPU and memory. One thing with the Factorio image that they put in there is if there's no users connected, it will actually pause. So you're still paying for the memory or the Fargate task running in that service, but the game won't be doing anything. It'll pause the game, and the memory and CPU allocation and utilization will, or not allocation, utilization will go much lower. So if we look here, here is our task, or here's our service, and then here's the task. And move this closer to there. So this started 2 hours ago, and we can see the configuration here that was set. 8 gigabytes memory, 4 virtual CPUs, and it's launch type Fargate. So if we go into it, we can see details. Again, everything that we look, capacity provider is Fargate Spot. And now here we actually have the public IP. Anything else? So we can see the container that's running. We can see the task definition if we want to. We can see logs if they are there. Since 1 hour ago, let's do 1 day. Here we go.
Hey Tycko, sorry to jump in your stream like this. Do you mind zooming in a little bit onto the screen? Some of these parts are a little bit hard to see.
No problem. Thank you.
Perfect. Yeah, that was great. Thank you.
Anything you go back to that missed because of that?
No, I think we're all good. This is perfect. Thank you so much. I'll jump back into the background. I'll fade back.
Thank you, Jonathan. Let's see. Let's move this down here. Yeah, logs. So we can see here with the logs, there was some sort of connection issue, missing token, but it is up and running. So here's the public IP address. One thing that I found with trying to go with the EC2 version of ECS, where you set up the EC2 to run, and then the ECS service runs on that EC2, or runs the Docker service on the EC2. Needed to put a load balancer in front of it. I was trying to play with it where I didn't need to do this, but one really nice thing about Fargate that it's just put it in the public subnet. You get this public IP, and so if anybody wants to, I'm going to go ahead and jump into Factorio here in a second, and go ahead and try to connect to it and see, pray to the demo gods that it works. So if we go to load up Factorio, and please let me know if is it showing on the screen? Looks like it is. So I can go into the menu, and for anybody that wants to, I'll go ahead and leave this up, but I believe the demo version of Factorio is able to connect for a little bit. I'm not sure. I've owned this game for probably 6 years, so I'm a little past the demo, but if you go into multiplayer and then connect to address, put that IP address, and it actually changed from a few hours ago when I connected. It went ahead and loaded up, and now I am in Factorio. Is there anybody else that has Factorio that's planning to connect? Give it a couple of seconds here. If not, I will go ahead and get out of this, but I could leave it up if somebody else is trying to connect and see if it works out. Does not look like it, so I'm going to go ahead and quit the game and go back to here. So looking at the time, uh, a couple things I mentioned earlier. Here is the cloud formation template that I started working off of that was EC2 based. Is really clean. You can just launch a stack right into your instance. Does not need CDK knowledge. You don't have to worry about deploying. So if you have friends that aren't technically that don't want to get into the technical code and worry about that, this is a pretty easy way to get it up and running. And again, that's based on the Factorio tools, Factorio Docker image. So looking at the cost, for the smaller server, I think it was like $10 to $20 a month. For the larger one, I think I was looking at 40 to 50. And that's if I left it on all day, every day. Actually, next up, we can go into that. So I'm going to go ahead and show how to put this down to 0. If we go to the service, service, I actually did not look at this. Update service. And I can go desired task back to 0, update. So that's all it takes to go in there if we're done playing for the day and don't plan to for a week, and don't have anybody that's going to hop on during that time. We can just do that. And then there, it shut it down. So we're back down. The only thing we're paying for is the EFS for the save data, which generally is a late stage game is a couple hundred megabytes, I think. So it's very inexpensive. And then let's see, um, give it a little bit of time or time it here, how long it takes to spin that back up. So here this stopped, and it is provisioning. So this will probably take about another minute or so. Yeah, so the next question, Fargate spot instance. I mentioned this is not a service that needs 100% uptime. If the spot instance is reclaimed, which I haven't seen happen while we're playing, it'll just spin it down and spin up another one. And so basically the time we wait is right here, and it is up and running. And I could go back into Factorio and see, but let's go in here and look at the IP address. So now it has a new IP address. I will just go ahead and do that. And we're back up right where it was. Any other questions in the chat before I move on? Um, that's a good question about scaling. I haven't had the need for it. It's the amount of money I would save on this for my personal stuff is not does not equal the amount of time spent on doing it. But that is definitely something I've thought about. It'd be really cool to do, and maybe when I get a little more time, I'll work on that. Any other questions? Okay, so that's the service as it works. Something now that I'm going into. Yeah, we'll go back just give you a brief, I did not actually get the EC2 version working, but I had some stuff come up this month that really took a lot of my time. I was pretty close, but I did start another set of stacks that instead of the Fargate for ECS, it goes ahead and starts up a EC2. A lot of the code's the same, EFS, doing that for persistent storage. Um, the main difference, I believe, is when we get down to the clusters, having to use key pairs for it, and then doing an EC2 service instead of a Fargate service. Now, this one going into the difference is what's required, especially if we get the large server and it's costing a bunch of money, especially just for personal use. What you have to do instead of going into the service and desired task to zero, you can do that, and then also while that's happening, you have to go to the automatic scaling group in EC2 and change that to zero. There's a little bit more involved to go do that, a couple extra steps. And then I found it's generally a bit slower to do that. And I think I ran into some issues with it. Again, I didn't spend too much time on it. Uh, one the biggest thing that took my time that I was trying to get around was I could not find a way to deploy out an EC2 version of it without putting a load balancer in front of it. And due to the nature of I only want one server at a time, I didn't really need the load balancer. So I was looking through that and ended up adding the load balancer, which is extra amount per month for how long it's active. And I believe there's no way uh, to deactivate that when we're not using it. So again, back to the serverless perks of using ECS Fargate. We can spin it down to zero. It spins up and down quickly, and to me, it had a lot fewer headaches. So it's there might be some trade-offs with having to be a more managed service, but those trade-offs were not felt by me, and it was very much the way to go. So back to the presentation. Um, as I said, easier. Uh, Whatever you do, especially if you're viewing this and you want to set up your own server and you're doing a new AWS account, make sure you set up billing alerts. That has saved me a couple times when I was messing around and forgot to turn something off. There's some jokes there about losing a bunch of money to EC2s running, forget to turn them off. So billing alerts, figure out about how much you want to spend a month, and put a couple alerts to the month. That's like if 10 days into the month, a third of the month, put an alert for a third of your budget. Um, the auto updates the IP addresses every time the Fargate task spins up, because I'm not using a load balancer or Elastic IP, which both cost more money, and I can just look up the IP address myself. That's a thing that happens. It doesn't happen too often if we aren't messing with it. If we just leave it on, it might be every couple of weeks that it resets. But that is something that sometimes we have to go in and ask, hey, what's the current IP? I did have it for the EC2 back when I was using the original CloudFormation template. Um, I set up a Lambda with a function URL that went in and got the IP address for the current one, and so it had that link. There's other ways if you want to get into it, if you're a longer running service and maybe you want a domain name or something. There's other services that you can use to make sure that you keep that new IP address, or each time it spins up, it's a permanent location that everybody can connect to and you don't have to find the new one. ECS Fargate scales to zero. ECS EC2 does as well, but it's more steps and can be a little confusing with what services you're starting up, especially if you're not or you're newer to it. Uh, it feels like Fargate has fewer moving parts, again, because it's more highly managed. Um, I did not get into it yet, but I did want to talk a little bit about it. Maintaining the EFS with Factorio, you can go in and mess with the settings. You can put passwords on the server. You can set the max amount of people in it. If you're starting a new map, you can set the seed of the game. Um, and so to do that, you have to access the EFS. I was not doing it the best way, but on the GitHub, there are instructions for spinning up an EC2 using that security group that we put in there, applying that to the EC2 so that it can connect to the EFS, and then mounting the EFS and the EC2. And then we can use stuff like MobaXterm or other easy GUIs that allow you to open and modify files. And then you just tear that down when you have things set. Another thing with the EFS, if you have save files, accessing those, saving them to your local computer, if you're starting a new server and you want to keep those, things like that. Or if you have a different server and you want to bring that save over to this one, you can just go in there and replace the save files this way. I did not get time to implement it, but using Systems Manager, there's ways to access the EC2 or the ESF, get my acronyms right, the ECS Fargate task. Um, and that way you could probably access it. I did not get to that yet, but it's on my list of things to look into for a much easier way to maintain that EFS. Last up, the solution is extendable. One of my interns took the GitHub, forked it, and uh, made it for Minecraft, and we spent some time in there. So if you have a Docker container of a game server and you know which ports to forward, it's pretty quick to get it in there and make your server for it. So that's my presentation. Thank you all for attending or watching later. And any questions that came up through this, I can stay on for a bit and answer them.
Hey, Tycko, great presentation. There are a few questions actually that I could help take you through or anything like that if you have any questions about where to look for those. I'm not sure if you're able to go back to the StreamYard stream, but those are going to be where all the comments live, and I can bring them up as they come up. We had a few questions from this guy, Buff Tomato, at the very beginning, asking you if you've ever built another dynamic server before and what unexpected issues that you ran into when setting this up.
I've built other servers usually, back early 2000s with Linux boxes and things. This is my first one on the cloud for game servers. Generally, I work with serverless. A game server, you kind of need that persistent connection and running that whole time. So that's where Fargate is great. I usually try to go with, for more traditional servers and whatnot, servers or services, the Lambda, S3, DynamoDB, API Gateway. So I don't generally do a lot of servers, but have done it that way. For other games, I mentioned at the end there, forked the repo and changed the Docker container or Docker image that was pulling to Minecraft, and then changed some of the mappings for the ports, and then it was up and running.
That's awesome. It's very apropos that you mentioned Minecraft. I'm not sure if you were seeing any of the comments come in, but someone else mentioned creating a Minecraft server setup with EC2 or not using EC2, but using AWS. So we can get to those questions in just a little bit, but very apropos actually. We have another question from Danielle. And if you had the stats, she would love to hear how much this costs to run per month, if you knew.
Yeah, and I'll go ahead and re-answer. I think I answered that in the middle, but just making sure. The For Factorio, the early game is very not CPU or memory intensive. If you get into like the mega base stages and whatnot, uh, it taxes the system. So for the early game, it was like $10 to $20 a month for what we put, and we weren't hitting the, the limits on that. So it's just something we wanted to do there. For the later one, I think it was about 40 to 50 a month. And then I got to the point where uh, my internet connection was not good enough to stay up to date with it, so I just pulled it locally. But I actually do not know much about the best way to host that at that scale for Factorio, what they do. But yeah, everything was sub $50 a month for the maximum one.
That's awesome. Yeah, that's really affordable. From Daryl, I'm not sure how many of these questions you've answered through. Then, so if one does come up that you already answered, just be like, I've already answered that. You can go back through the video. Feel free to. All right. So Daryl let us know that he missed a bit of the presentation, but he was wondering if your code could handle the Fargate spot instance getting reclaimed and save
Yeah,
state PR, do things, start over, stuff like that.
and I'm happy just to answer it again. I did
Perfect.
answer this one, but just
Cool.
bringing it up in case people skip to the end for the questions. This service, when we were playing, we did not need 100% uptime. We only had one server going at once. We could have had multiple and done some load balancing potentially if it went down. I don't think I ever saw the AWS take back the spot instance, or is it reclaim the spot instance? But as we showed in the going through it, if that did happen, it was just within a minute, backup. And unlike me scaling it to 0, the service would know, and I think it might even start before it. I think the service is aware that it'd be reclaimed, and so it would try to start and just switch it over. So it'd basically be us disconnecting from the game, and then reconnecting to the game.
Awesome. All right, and another question that we have that you may have already answered, but it's good if you have, then to reiterate, from David. He was wondering if you've ever thought about auto scaling to 0 when there's been about 30 minutes of load.
Answering it a little bit more. I don't know if we're leaving it on and we just want it ready. I don't really want to wait even a minute. So oftentimes we just leave it on. But that is something, especially if it got larger and if it was just me playing on it, I probably, it'd be interesting to look into that. And I know there's ways to do it. I just haven't done it.
That's awesome. Well, I don't know if there's too many other questions that are burning in here, but there are a few comments I wanted to pull up. Let's see. From Daryl, really cool, Tycko. Thanks for showing this. And then from Shilling Mike, thanks for sharing. Great presentation. So yeah, this is really cool. Yeah, I'm really excited about downloading my own game of Factorio and trying this stuff out. So
or Minecraft, right?
Or Minecraft. That's true. I can meet Daryl in Minecraft. We can create some. We can create some servers together. Yeah, this is great. If you guys go through and download Factorio yourself and try this out, please let us know on the Believe in Serverless, socials or on our Discord. It'd be great to see any kind of follow-ups or anything. If anyone creates their own, maybe we can also do like we can all go on Discord and create a Factorio channel, and then we can just play on the same server or something. So a lot of cool ideas come from this, Tycko. Yeah, but I don't want to steal a spotlight too much at the end here. If there's anything else you'd want to say or plug or anything like that.
Yeah, just closing out. This is for a game. This is my personal stuff. This pattern works for more than just games. If you have any sort of server that you need running that is Dockerized, you can swap out a couple things, and this works for any Docker server based workload. Well, I shouldn't say any, asterisk there, but yeah. So thank you all for having me. It was a pleasure to share, and I had a lot of fun working on this. So see you around in the community.
Sounds good. Thanks, Tycko. This was great. If you guys use this, or for Asterix, almost anything that uses Docker, let us know. And for any questions or comments like that, Tycko, is there anywhere that people could find you on socials or anything like that
Yeah.
if they do need to follow up? Have any
Yep.
questions about this?
So I'm on LinkedIn in the Discord for Believe in Serverless. Just get my name. I think it's pretty unique, but if you have trouble finding it, yeah, hit me up and Believe in Serverless, and we can find a way to connect.
Awesome. Yeah, find Tycko on Believe in Serverless, or find him on LinkedIn and reach out if you guys need. Thank you so much, and this has been another amazing webinar here from Believe in Serverless, and we hope to see you on the next one. Thanks,
Thank
guys.
you, Jonathan. Bye.
Thanks, Tycko. Bye.